All right, so for number 7, we have that a function is defined by f of x equals 2 minus blah, blah, blah for these x values, see? And x cannot be that. So all this thing on the right side is actually my domain, all right? Later on, for part A, they ask us to find the range of f. So because we're in the world of domain and range, let's take a moment and explain that for a second. Domain is essentially going to be your x values, see? Range, on the other hand, is going to be your y values. And so what happens is that in order to get y values, you need to plug in x values. What do I mean by this? The x values, you plug them into your f of x. This gives you a y value. See? What x values can I plug in this case? These ones here. Which one can I not plug in? Anything beyond that and -5. See, so those are the ones I can't plug in. The ones I can plug in are boxed in right now in orange. See? And so that's going to spit out a bunch of y values, and that is exactly the range that we're trying to find for part A. See? And so of course you can spend a lot of time plugging in -7, -6, -5, -4, -3, etc. and see what happens. But there are some faster ways to figure it out. See? I think the quickest way is taking a moment, opening up your calculator, going to y equals, and plugging in here so that we can graph. See? So I'm going to plug in f of x right now. It'll look something like this, 2 minus fraction, ¿cierto? For fraction, I can do alpha y equals, hit the first one, and boom, I can plug in a fraction very easily. There's other ways, but hey, whatever floats your boat. See? Since we are graphing, let's go ahead and pull up the window. See? So window here kind of like defines what my graph is going to show. Since I know that my domain goes from this to this, I'm going to put exactly that. So minimum x -7, maximum x 7. And for y for y min and y max, we can eyeball it later, see what's going on, but for now, I think this is fine. So let's graph, see what happens. Beautiful. So if we take a moment and look at this graph, I'm actually going to draw it down here because I'm going to spend some time talking about it. We can see that at -7, I have like a big value over here that goes all the way up. And at +7, it kind of reaches a maximum and then goes down. See? And so what I need to do for the range is see what what y values this reaches. See? And what y values this reaches. See? And so once I define all of that, whoops, that's not very good. Once I define all of that, I will be good to go. See? Awesome. So everything in between is not my range. See? Everything right here is not my range because I'm not touching anything on my function. Everything in yellow is because it is touching something of my function. See? So that is the game plan. Let's go with the top left first. See, so this top left, we take a moment, we analyze it. We see that there's a -7 here, ¿cierto? So I can plug in -7, and from -7 upwards, ¿cierto, is going to be my range. Let's see what happens. So if I plug in -7 for f of x, we have 2 minus 12 divided by -7 plus 5. This gives me 2 minus 12 divided by -2. Double negative, I end up with 2 plus 6. This gives 8. See, so what that's telling me is that this point here is 8. And so my range right on -7 is telling me that, hey, when I have -6, for example, I also have a very big number. See? So I don't know what it is, but it's bigger than 8. And so my range, we can say, is going to be, give me 1 second, something like this. Greater than or equal to 8. See? This right here means your y values or your range. Another way you can write it is like this, which for me was always more intuitive. Whatever floats your boat. See? And so my y values are actually greater than or equal to 8, which makes reference to this 8 right here. How did we find that 8? By plugging in -7. How did we know to plug in -7? Because we graphed it, looked at it, and we could tell, hey, from -7, as it grows, we have growing values here as well. All right, so that is for the top left. See, let's do the bottom right for now, ¿cierto? So as I mentioned earlier, from 7 to like some point here, ¿cierto? It's like decreasing, ¿cierto? It's decreasing and we gotta find out what's going on, ¿cierto? So what we can do is plug in the point of 7 and see what y value this gives me here, see? And so whatever y value I get there, I'm gonna say, hey, it's all these y values, and the ones below it. See? It'll make sense, more sense in a second. I'm going to plug in f of 7. See? So that's going to give me this point here. And in consequence, that y value there. So f of 7 is 2 minus 12 divided by 7 plus 5. 2 minus 12 divided by 12, 1. So this point here is 7, 1, ¿cierto? Which means that this point here is also 1. And so essentially, all of these values that I have in yellow, that I will now draw again in purple, let's say, ¿cierto? All of these have a y value of 1 or less. All of these have a y value of 1 or less. In the other case, we had a bunch of y values that were 8 or more. See? So here is 8 or more. Here is 1 or less. Ladies and gentlemen, this is for part A. So you can leave it like this. If you want to get very fancy, you would leave it in the other form that looks like that. See? But honestly, this explains the same information. This is your range of your function. See? So that is for part A. For part B, we need to find the value of that. See? And so what the heck is that? That makes reference to the inverse function evaluated at 0. See? So let's start first by getting the inverse function. I have more space down here, so I'm just going to do it over here. We know that f of x is 2 minus 12 divided by x plus 5. See? So if we need to find the inverse function, the best way that I can explain it is that your x and y are flipped. See? And so to find your x and y, to find the inverse function, the most intuitive way, I think, is saying, okay, I'm going to plug in y for this. See? And now I'm going to flip my x and my y. And it'll look a little bit like this. I will have x on this side equals 2 minus 12 divided by, bada bim bada boom, y plus 5. So notice that my x and y were flipped. See? After I flip them, I want to get y alone. Once I get y alone, that will be my inverse function. See? Once I have that inverse function, I will plug in 0, and I will be done with the problem. So anyways, that is the most intuitive way I can explain how to get the inverse function. So I need to get y equals somehow from this position here. Because I have y on the bottom of a fraction, I want to get rid of that right away. It's super annoying. The best I can suggest is multiply everything by y plus 5. Why do I do this? You will see in a second. So I multiply this by y plus 5, this by y plus 5, and this other guy by y plus 5. The reason I do this is because this guy here goes away with that guy there. Suddenly, my variable is not on a fraction anymore. It's much easier to deal with. See? So if I write it out real quick, we can see that this is much more friendly than what we had before. See, we don't like our variables in denominators. So now I'm going to distribute. I distribute on this side. I end up with xy plus 5x equals, distribute again, 2y plus 10 minus 12. See? Now I want to get all my y's on one side, so I'm going to throw them all to the left. I have xy minus 2y, which comes from this guy here. And I throw this 5x to the other side, so I end up with negative 2 minus 5x. See? Negative 2 because I combined these two. ¿Cierto? I end up with negative 2. Now, since I have all my y's on one side, which is exactly what I wanted, I need to factor. ¿Cierto? So it's useful to factor because it allows me to further get y alone. So y parentheses x minus 2 equals negative 2, negative 5x. See? Now I can divide both sides by x minus 2, end up with something like this. Negative 2 minus 5x divided by x minus 2. Why do I divide by x minus 2? Well, it's what I factored by. It allows me to get rid of these two. I end up with y equals something. ¿Cierto? This was our big goal, getting to y equals something. That something is this. And this right here, ladies and gentlemen, is my inverse function. See? This right here is my inverse function. And so since we need to evaluate our inverse function at 0, I just plug in 0 for x. So negative 2 minus 5 times 0 divided by 0 minus 2. This ends up being negative 2 divided by negative 2, which gives you positive 1 because of the double negative. That is part B of number 7.